Putting a real fridge anywhere, -20 degrees Celsius on the beach or in the mountains, it's now possible without the battery. I use only a pack of supercapacitor as a buffer and a little Genio MPPT brain. And you need also the sun. Even when it shines only from the dawn to the sunset, your milk, meat and medicines will survive the night. So in this video I will present a unique combination of the MPPT solar charger and the supercapacitors. And where will you find that? Hi, I'm Norbert, I'm an energy engineer, and in video number 138 I will start our first project with the PV2COM playlist. We will see how to connect a small but efficient fridge box and a PV panel. In video number 137 I presented PV2COM, and that's direct energy, solar energy coupling to produce commodities. That's things that you need every day, like hot water for the shower, or cold water for the fan coiler, drinking water, conserved food, or compressed air. You name it and the sun makes it. And today we go from theory to the hardware. I have a 245 volt panel, a Victron MPPT brain, and this, a real 50-liter compressor fridge that can hit -20 degrees Celsius. But you can also set the temperature at a modest +3 degrees Celsius. There's a problem with this direct connection between the PV and the fridge. A compressor isn't like a light bulb. It's a mechanical beast that needs a bootstrap to start. And when a cloud appears, it will shut down immediately and will take an obligatory compressor pause of a few minutes. That's not nice with so many clouds like in Northern Europe. So how do we handle that without an expensive heavy battery bank? I will experiment with two options. A small lithium battery of 8 ampere hours. Well, this is an old one. It is a LED battery. The lithium-ion battery must come tomorrow. And that I will put against the supercapacitors with the long life, as long as the PV itself. And when you want to add a real big battery to harvest all the energy that the fridge doesn't ask for with a big PV panel, no problem. The MPPT box has all the brain power to handle also your big battery. We use a tiny electric buffer instead of the usual dimensioned battery. Because we don't need to store electricity, we are storing cold. That's cheaper, it's more direct and also more foolproof. Every dark night is a blackout for the PV panel, but you don't care. So the electric buffer is not really storage, but it is just giving stability with clouds in the sky. So the conventional PV systems use batteries just to continue to run the fridge during the night. I have a little bit problem with this trend of today with batteries everywhere. It seems as if the solar energy trend is a big one-man show for electricity. In PV2COM, we let also other commodities enter the scene. They are filling the storage, be it in a tank or a box or on the shelves of your kitchen. And in our example today, it's the cold that we can also store. Here are the players to realize a system that's absolutely independent, on a beach, in the mountains or on a ship, developing or developed countries. Number one, we have the panel. 245 volts here and 24 volt. Is that over-dimensioned? Yes, but that's the point. We want power even in the morning haze and just before sunset. And PV is today not so expensive anymore. Then we have the brain, the Victron Smart Solar 7515. And this is our MPPT and it's like the gearbox in your car, which adapts the fast spinning engine to the high torque on the wheels. And then you have the buffer. I have here two alternatives, an 8 ampere hours lithium battery, or that old one that I showed, and I have a supercapacitor bank. The supercap is amazing. It can charge and discharge millions of times. It will maybe even outlive the PV panels, and it delivers a massive current bootstrap for the compressor startup. But it has almost no capacity. Maybe 5 minutes with a medium and 15 minutes with a larger panel. But in many warmer climates that's enough to run this combination in the 5 warmer months. From the other side, the 8 ampere hour battery has much more energy, even if it's much less than a car battery. So which one wins and in which situations? I will show you the results in the next video, but today I want to explain you the logic. And finally we have the fridge. Don't try to do this experiment with a cheap cool box of 50 euros, running on inefficient solid-state Peltier elements. Only a real compressor fridge arrives at 4 degrees Celsius or even minus 20 degrees, and with less energy for each bottle of milk. A good approach to survive the night is to produce ice bottles with this fridge. That represents a lot of energy already. You can put them together with the food in another well-insulated cool box. This saves you hundreds in lithium batteries. I took a rather big fridge box in order to show that even that needs only 20 watts on average for maintaining foodstuff, and can therefore work with a modest panel from dawn to sunset. For producing ice, you need more energy, and that you can do during the hours around noon. Now the challenge is a startup surge and a volatility of the sun in many climates. Today I introduce a unique combination between the MPPT solar charger and the supercapacitors. And usually the MPPT is made only for batteries. The first challenge is a startup. A DC compressor might pull only 3 ampere during normal operation, but it needs 10 ampere or 15 during a fraction of a second when it starts. Now look at this battery. It's a battery that I have today. Tomorrow will arrive the lithium battery of the same capacity. But this battery is not able to start this fridge. But that's where the 500 Farad Supercapacitor comes in. And then you have the other challenge, and that's the volatility of the sun. Even the small old battery still stores more energy than that supercapacitor. I'm so glad that I don't have to discard it now, because together they offer what they don't have if they are alone: capacity and power. So you can put them together, or you can take them one or the other. That depends on your situation. It depends on your climate, your size of the PV panel and your fridge. So I've got the parts, I have the plan, and in the next video I will flip the switch. But don't leave yet. At the end of the video I will show some experiments, some really nice standalone experiments. So what do you think? Is a supercap enough, or do we need the chemical energy of the 7 ampere hour battery? Let me know in the comments. And don't forget to subscribe for a full experiment of PV2COM with the fridge. I'm Norbert, energy engineer, and I can't wait to build smarter solar energy with you. And I wish you good energy.